Hey, I'm Adam from Cardboard Studio. In this clip I'll walk you through creating a player chasing stamina sprinting sentry. When it's not detecting the player, it will follow a pattern routine, and when it detects the player, it will chase him. Bot will be able to forget about the detected player. Bot has an amount of stamina used during sprinting and regenerating while standing or walking. Before we continue, let's play a bit with our bot. Check out his behavior tree on the side. As we can see, bot is currently running the TPC patrol node. He's looping endlessly on his routine. Now, as soon as bot detects the player and becomes aware of him, he will start chasing. And as long as he has some stamina, he will sprint. Stamina decreases during sprinting and restores during walking or standing. Once bot runs out of stamina, he is forced to walk. Users can set initial stamina amount, stamina recovery rate per second, drain rate per second, and more. I split this video into parts, so you can watch it all or jump to what you need. Timestamps can be found in the description. And if you already watched one of my previous clips about creating a sea sentry, you can jump straight to the tree creation section. To make this sentry work, you need three assets. First, started assets, third person, which is free Unity package. Comes with a third person character controller, animations and demo scenes. Grab it from the Unity asset store, link can be found in the description or comments, and import it into your test project. Second, senses, created by me, lets you add senses to your enemies or NPCs. And finally, AI navigation. We'll use a NavMesh agent, so open Package Manager, find AI navigation and import it. Important note, the new TPC nodes can run without NavMesh using position-based movement, but I prefer proper pathfinding and obstacle avoidance. After importing all of the assets, go to Started Assets, Third Person Controller, Scenes, Playground. Open up the scene and hit play to check. Camera moves with the mouse, character moves with the keyboard. Perfect. Now, let's prepare our player character. Just add one component to the player, target senses, and that's all. Let's focus on preparing the bot. We'll do 5 quick things. In the hierarchy, find player armature, duplicate it and move it aside. Change the name to the rob the bot. Inside it, find armature mesh. Duplicate the materials, change the base color, I'm going with purple, and assign them back. Nice. Secondly, we need to disable player input on the rob. The new nodes will turn this off automatically when they start, but if you leave it on, you can mess up player controls. So, to be sure, we turn it off. Thirdly, let's add senses component. Click Add Next Sense and choose C. Assign the Ice transform head transform will be perfect. Set central vision angle to 30, range to 12, and enable display FOV. Enable peripheral vision. Set angle to 45 and range to 6. Enable able to forget, so Rob can forget the detected player. Sweet. Fourthly, add a NavMesh agent and set the stopping distance to 1. And finally, add a executor component. Create a new behavior tree asset and assign it to the executor. Finally, we should be done during setting up our bot. Time to prepare NavMesh surface. Before we continue, if you have FOV displayed like me, you need to remove it from the scene, cause NavMesh will treat it like non-walkable area. But fear no more, Agent will add it on his own when he'll need it. Select ground, add component, NavMesh surface, leave it as walkable. Guess what? Seems we don't need to select anything more. Hit bake. Wait a few seconds, turn on gizmos. You should see a blue walkable area with clear spaces around the orange boxes. Since we are using a patrol action node, we'll need a waypoints for our bot. Create a new empty game object, duplicate it a few times and spread them around the level. The order in the hierarchy equal patrol path order. Now we got a simple waypoint path ready for the patrol node. Time to build our stamina sprint Sentry behavior tree. Open the tree, double click the tree assigned in the executor and rearrange the workspace. Done. Click Rob the bot in the hierarchy to open and inspect his blackboard. Add repeat decorator, then connect it to the root node so our tree runs indefinitely. Add senses was anything seen fork node. Set awareness threshold for bot. Choose everything in faction dropdown. Set search type as nearest in both angles. Enable in senses range here. Now let's add TPC chase action node. Connect it to true output port. Now let's add TPC patrol action node. Connect it to false output port Assign waypoints from hierarchy to Blackboard hard-coded on bot. And finally, enable use NavMesh on both TPC Chase and TPC Patrol. Before we continue, let's enter play mode and check out Rob the bot behavior tree. As we can see, Rob starts his patrol routine. When he detects the player, he starts chasing. So far, he can't sprint yet, but we're getting there. Let's exit play mode and upgrade our behavior tree. We need to add TPC set sprint node. This node will turn sprint on. Also, I will add a quick node to this node so we can see what is his task. Now let's copy and paste this node on the second side. This one will set sprint off. We'll add another node on him. Next, we need a node that allows calling multiple nodes in sequence. Perfect choice will be sequencer node. We'll use two of them, each for one side of the tree. Let's move up the root node, repeat node and sense as was anything seen. Then place our sequencers below and start connecting nodes. Each sequencer in Rob the bot tree will have two nodes connected. Just like that. We are almost there. I forgot to change the second TPC set sprint state to false. Do it here. Now we are ready for tree testing in play mode. Rob patrol along his waypoint path. When he detects and becomes aware of the player, he starts sprint chasing. When Rob loses track of the player, he goes back to walking. Nice, so far Rob can walk during patrol and sprint chase. So it's time to introduce the stamina node. I added a dedicated decorated node to handle stamina. This solves key issues without needing multiple nodes. Remove sequencer and TPC set sprint node here. Add our TPC stamina sprint decorated node. So why this node rocks? It lets Rob change sprint state during chase instantly when stamina runs out. And this change doesn't depend on tree structure, it happens automatically. Let's connect everything and inspect the TPC stamina sprint node. Initial stamina amount sets how much stamina Rob starts with. Recovery rate per second, how fast stamina restores while idle or walking. Drain rate per second, how much stamina is lost while sprinting. Sprint restart threshold prevents early sprinting before enough stamina is restored. With value 1, fully recovered is required. With value 0.5, half of the stamina is needed to sprint again. Currently, By default, node is connected to Blackboard hard-coded variables, but user can change this. Now let's enter play mode and enjoy our tree. Rob start patrolling. Once he detects and becomes aware of the player, he sprints. Remaining stamina is shown in the node bar. When it drops to 0, Rob is forced to walk. If Rob walks or stands still, stamina recovers automatically. And check this out, even without TPC sprint stamina active, stamina recovery tracking still works. Looks nice, right? So before we finish this video, I'd like to present you one more advanced feature. So TPC stamina sprint can synchronize with other TPC stamina sprint nodes. As a result, Rob can use stamina not only for chasing, but let's say also for fleeing. So check this out. Let's remove sequencer and set sprint node here. Inspect existing TPC stamina sprint. Enable sync remaining stamina here. Now copy past decorator node and reconnect. Let's enter play mode and check it out. Now Rob stamina is shared across patrol and chase. If he has enough stamina, he can sprint to the next waypoint. When his stamina drops to 0, he's forced to walk. He's still able to detect and chase player when needed. Key point here is fact that stamina is shared across behaviors. And that's all for this episode. If you have any questions or on the issue, hop into Discord. Link is below. Thanks for watching. I'll see you in the next one.